Alright, today our lesson is going to be about dividing powers. You know, our last lesson was on multiplying powers, and you learned that if you multiply powers that have the same base, you add the exponents. Today you're going to see that division is similar, but the opposite. Today you're going to learn that when you divide powers with the same base, you subtract the exponents. But before we get on to the new stuff, I want you to take a minute. I have 8 problems here to review to help you practice for a possible upcoming quiz. So you can hit pause, work out these 8 problems on a piece of paper, and then when you're finished, unpause it, and then we'll go over the answers. So hopefully you've worked out these 8 problems by now, and we're going to look at the answers. Number 1, you have a power of a power, an exponent raised to another exponent. So hopefully you multiplied the powers. And this answer, well, that's actually wrong. It's going to be 10 for the base. It should be x to the 6th power. Number 2, you have a negative exponent. So hopefully you remember to make this a fraction. And that would be 1 over to the 3rd or 1/8. Number 3, you're going to have to simplify each of these parts. 3 squared is 9. X to the negative 1 is 1 over x. Together, get 9 over x. And number 4, we have a product, or power of a product. So the factors in the parentheses needs to be raised to the negative 3 power. And when you raise a power to a power, you multiply the exponents. So v to the negative 2 to the negative 3 is v to the 6th. And this would be w to the negative 9, which you'd then denominator. Your answer is v to the 6th, w to the 9th. If you missed any of these problems and you're not sure why, make sure you ask me in class or come to a tutorial to find out. Number 5, your answer should be 3 to the 6th, or if you calculated what 3 to the 6th is, that would be the same. Number 6, y to the 3rd over z to the 3rd. Number 7, you have to write this in scientific notation. It's not in scientific notation because 30 is not between 1 and 10. So move the decimal over and then change the exponent. The correct answer is 3 times 10 to the negative 2. And finally, number 8, 1.6 times 10 to the 6th. Again, if you missed any and you don't know why, make sure to come see me in tutorial or ask me during class. We're going to move on to learn about division property of exponents. I believe there's 4 different parts to this lesson. The first one, dealing with quotients of powers. So how do you divide things that have exponents? Like I said a little bit ago, this is similar to when you're multiplying powers. You know, when you multiply powers that have the same base, you add the exponents. In this case, when you're dividing, the powers have the same base, you're going to subtract the exponents. And let me just give you a short explanation of how come. 3 to the 5th, that means 3 times 3 times 3 times 3 times 3. And then 3 to the 3rd is 3 times 3 times 3. Now, if we simplify this, remember, what is 3 divided by 3? Hopefully you remember that that is 1. So those essentially cancel out. Those 2 can cancel out. And we'll make those 2 cancel out. So what do you have left? 3 times 3, which is 3 squared, or 9. And again, we had the same base. 5 and 3 were the x. 5 minus 3 is 2. That's how you get the answer. In this problem, x to the 4th divided by x, dividing, powers have the same base, so subtract the exponents. What is the exponent of 1? Hopefully you remember that's understood. The exponent of x. Hopefully you remember that's the understood 1. So we have 4 minus 1, which is x to the 3rd. I have typed out the rule here. The quotient of any 2 non-zero powers with the same base, and again this only works if they have the same base, it's equal to the base raised to the difference or subtraction of the exponents. So let's look at these examples. If you want to try them on your own first, hit pause and work them out. If you want to listen to work these out, that's fine as well. Example A, we got a division problem. Have the same base, so we're just going to subtract the exponents. Keep in mind, you do not actually divide the bases. You don't do 2 divided by 2 is 1. Keep the base, 2. And 7 minus 2 is going to give you a 5. And if you want to go ahead and work that out, 32. In example B, dividing, same base, You have a to the fourth minus negative 3, which would give you a to the 7th. Example C, again, writing, have the same base. M to the minus 5, that would be m to the negative 3. The problem here, that answer fully simplified. Hopefully you remembered you cannot leave an answer that has a negative exponent, so you have to go ahead and simplify that so you don't have any negative exponents. I want to show you another way to look at this problem, to think about it. So let me just get a new page real quick. Alright, that problem was m to the 2nd over m to the 5th. If you think about this in longhand, like I started off, that's m times m over the product of all these m's. If we cancel, m divided by m cancels, and m divided by m cancels. What are you left with? Nothing in the numerator, so you have to put 1 as the placeholder. And in the denominator you have 3m's, so that's m to the 3rd.